Hello friends, today we will discuss the remaining questions of exercise of human eye and the colorful world. Okay, that is the human eye part is what we last covered, that is up to question number 9. Now here it is. Next question, why do stars twinkle? Here you can include one diagram also that is there in the textbook. Here there it is in detail we explained. Okay, then also as a question, okay, we can write it like this. Stars emit their own light, that we know, and they twinkle due to the atmospheric refraction of light. It is so here the important word, that is atmospheric. At the time of explanation also I told that okay, one point, that is you can say keyword, is this atmospheric refraction. Okay, why do stars twinkle? Okay, in single way, due to atmospheric refraction. Okay, now here stars are very far away from Earth, that we know that Sun is the nearest, and most of the stars are far away from the Earth. Hence, they are considered as the point source of light. Yes, the same explained there at that time. So when the light coming from the stars entered, that is other keyword, but it is point source of light. That is also a keyword. Okay, first is atmospheric refraction, next is a point source. Okay, when the light coming from stars enters the Earth's atmosphere, okay, it gets refracted at different levels. It is next is refracted at different levels. That is the other. Okay, this is the other important keyword. Okay, at a different levels. Sure, this is the other keyword. Okay, because then only it will move here and there. Okay, when it is of moving, that is, you know, that is different layers while it is of coming. Okay, now while it is coming, it will come here, then here. It is like this, it will move. So it is of coming towards like this. Okay, so that it is apparent position, you know that it is more little greater than this diagram also you can draw. Okay, now here this, you know that this is the original position and this is the apparent position. Okay, now because of the variation in the air density. Okay, why it is so happening? Because of the air density at different levels of the atmosphere. You know that now in this level the air density will be different from in this level. Okay, so that there is a deviation. Okay, and air density at a different level. Now here again other. Okay, why the refraction is there? Because of the variation in the air density. Okay, at the different level of the atmosphere. When the atmosphere, okay, refracts more star light towards us, okay, the star appears to be brighter. Okay, that is if it next, okay, when the atmosphere refracts more sunlight, but it is more sunlight, okay, towards us, the stars appears bright. Understand? When the atmosphere refracts less starlight, okay, then it appears dim. Understand? Sometimes more and sometimes less. Okay, therefore it appears as if, okay, the stars are twinkling at night. Understand? Okay, like that it is. Sure? Okay. Now one more point, if you want, you can add that we still see that, so that because of the refraction, it is of continuously changing its positions. Okay, sometimes down, like that also. Okay, you can include the point. Understand? So this is the reason you get right. Why do stars twinkle? Okay. the star emit their own light, okay, and they twinkle due to the atmospheric refraction. Okay, these keywords you must have to note down. Okay, atmospheric refraction. Now stars are very far away from the earth, hence they are considered as point source of light. When the light coming from the stars enter the earth's atmosphere, it gets refracted at a different level because of the variation in the air density at a different level of the atmosphere. When atmosphere refracts more light towards us, the star appears to be bright, and when the atmosphere refracts less starlight, then the star appears to be dim. Therefore, it appears as if the stars are twinkling at night. Sure? Understand it? Okay. Then we will move to the other one. Well, that is here. Explain why the plant do not twinkle. Okay, now that also actually we see there. Okay, that there from there also you can study from the notes also. You know how it is. Now first is of plants do not twinkle because they appears larger in size. That is the one point. What is the reason? Because larger in size. They appears larger in size. They are not point source. Like that also you can include. Larger in size, not point source. Okay, that understands. As they are relatively closer to Earth, other thing. Okay, they are closer to Earth. That is far away from the Earth. Planets can be considered as the collection of large number of, this is very important, collection of large number of what it is, point size sources. Point source. Okay. Now the different parts of these planets produce either brighter or dimmer effects in such a way that the average of the brighter and here important point average. Okay, of the brighter and the dimmer effect is zero. Average is zero. That is refraction is taking place. It is not like that. Okay, refraction is not taking place. Refraction is taking place, but okay, the different parts of this. It is a many point source. Okay, so that when this one point is here and there, the effective. Okay, it is okay. The effective. Okay, or the average of the brighter and the dimmer effect is zero. It is that the when we are considering the average, okay, it is become zero. Okay, so we can't see it as a simple. Now this is what is the main point here. It is what it is. It is not a point source that is larger in size. Okay, so you can say like it is not a point source. That is the main point. Okay, it is not a point source. That is the main point here. Okay, that is collection of large number of point size sources. Okay, so the average of the brighter and the dimmer effect is zero. Understand? So like that you have to write the answer. Okay, that is planets do not twinkle because they appear larger in size than the stars as they are relatively closer to Earth. Planets can be considered as collection of large number of point sources of light. Okay, the different parts of these planets produce either brighter or dimmer effect in such a way that the average of brighter and the dimmer effect is zero. Hence the planets do not twinkle. Sure? Understand it? Okay. Then the next question we will move. Here, why does the sun appears reddish? Okay, earlier in the morning. These questions are of very importance. Okay. Now here this. Look. Here you know that. Okay, that is also. Here also you can draw the diagram. Okay, diagram also you can draw one diagram like this. Okay. Now here it is and the horizon. Here you know that it is like this. Okay, this diagram you can draw. Okay. Now here, during sunrise, the light rays coming from the sun have to travel greater distance. Here it is. Okay, important. But it is have to travel greater distance. Okay, that is important point. In the Earth's atmosphere before reaching our Earth. So during sunrise, okay, main point is okay, the light rays coming from the sun have to travel a greater distance, okay, in the Earth's atmosphere before reaching our eye. That is the important point. Okay, in this journey, okay, the shorter wavelengths of the light are scattered. Okay, so while it is moving, okay, too much distance, what happened? The shorter we studied that shorter wavelength, that means violet, indigo, blue, green, okay, etc. Okay, these are the main. Okay, these, okay, shorter wavelength get what it is are scattered out. That is gets away. Only the longer wavelength, which is the longer wavelength, orange and red, correct? Okay, able to reach our eyes. So among that, okay, spectrum, violet, indigo, blue, okay, yellow, orange, green, orange, red, okay, this, okay, shorter wavelength scattered off, okay, only the longer wavelength are able to reach our eyes. Sure. Okay, since blue color has a shorter wavelength, it is since blue color has a shorter wavelength and red color has a longer wavelength, the red color is scattered the least. Understand? Here which is the scattered the least? Red color is scattered the least and is able to reach our eyes after the atmospheric scattering. Here important point here, atmospheric scattering of light. Therefore sun appears reddish, okay, early in the morning. So sure, understand why the sun appears reddish early in the morning. Sure, during the sunrise the light rays coming from the sun have to travel a greater distance in the Earth's atmosphere before reaching our eyes. Okay, in this journey the shorter wavelengths of the lights are scattered out and only longer wavelengths are able to reach our eyes. Since blue color has a shorter wavelength and red color has a longer wavelength, the red color is scattered and the least and is able to reach our eyes after the atmospheric scattering of light. Therefore sun appears reddish early in the morning. Sure, understand well? Okay, these questions are very important. Okay, you just draw this in textbook. This diagram is there. Okay, you include this diagram also. Okay, now the next. Yeah, here the question is, okay, why does the sky appears dark? Okay, instead of blue to the astronaut. Now who is astronaut? One who's traveled to the space is called the astronaut. Understand? Who traveled to the space is called the astronaut. That is in space. That is in the question can be twisted like this also. Why does the sky appears dark? Okay, instead of blue to blue in space. Like that also you can say. Okay, in space, where you are going to the space, now there you will see everything in dark. Okay, there is no blue or nothing like that. Okay, now the sky appears dark instead of blue to an astronaut because, okay, there is no atmosphere. Yes, answer is that only. What is the answer is? No atmosphere. Okay, in the outer space that can scatter, otherwise, okay, scatter the light. So it is no atmosphere, therefore no scattering. And so in order to visibility, what is necessary is this scattering is necessary. Okay, so we can see the atmosphere because there is a scattering of light in the atmosphere because of the gas molecules, okay, different dust molecule, water molecule, etc. As the sunlight is not scattered, no scattered light reaches the eye. So that in order scattered light must have to reach us eye, okay, in order to, okay, see the atmosphere. Okay, the astronauts and for eyes of the astronauts, and the sky appears black to them. So it is very simple. So here what is the answer? Why does the sky appears dark? Okay, instead of blue to the astronaut, while telling about what it is, the sky appears dark instead of blue to the astronaut because, okay, there is no atmosphere in the outer space that can scatter the sunlight. Sure. Okay, as the sunlight is not scattered, no scattered light reaches the eyes of the astronaut and the sky appears black to them. Sure? I hope you understand it well. Okay, so that was about it. Okay, you must have to study it again and again. Okay, and the written practice is very important. Okay, once you study it, what you have to do, you have to write it. Okay, once you write it, you will remember it more. Okay, so thank you students. Bye. Have a nice day.